Okay, let's start this class. Everybody, please open your camera. When we learned this thing, it felt like you learned this before. So this is not something new. If you learned the 7th grade AAC, you should already learn the 3D geometry surface area calculation. Okay, let's take a look at these kind of questions. First, we see a cylinder. How do you form a cylinder? You can use a rectangular paper. If you have a rectangle paper like this, and you can hold it and make a circle, and this becomes to a cylinder. When you open it, if you cut through the side and open it, it is a rectangle. So that means the lateral surface of this cylinder is going to be this. This length is the same as this circumference. If the radius here is r, then this circumference will be 2 pi r. So this will be 2 pi r. And that guy is a height, which is 7. So 2 pi r by h is going to be the lateral surface for this cylinder. And you have a circle on the top and also on the bottom, which is pi r squared and pi r squared. And then number 2. Look at this. The top and the bottom are both a hexagon. It's a regular hexagon. It is composed by, a hexagon is composed by 6 equilateral triangles. They mark here as 8, so you should be able to calculate that's 8, that's 8, that's 8. And then I'm going to call student to do this equilateral triangle area. Elizabeth, please unmute yourself. Let's see number 2, okay? Yeah, go ahead. Number 2, we can see this one. This size is 8, this size is 8, and this size is also 8. We can use the trigonometry we just learned, or we can just use the Pythagorean theorem. Doesn't matter, okay? Go. How much is this angle? How much is this angle?
I don't know.
Equilateral triangle, each angle is how much?
60.
This is half of this, so this will be
30.
30. So this is 30 degree. 30 degree right here. And then 60 degree right here. So far, so good?
Mm-hmm.
Then go ahead. Just use the trigonometry we learned last week. Go ahead. Go. I want to calculate the h. You want to use cosine or you want to use what?
Oh, so sine
You don't use sine. Sine is this. You already know this part. You want to use cosine, right?
Oh, of 60 or okay.
Sine, cosine is 30.
30 is h over 8.
Cosine 30 degree equals h over 8. Cosine 30 degree also equals to who?
Cosine of 30 degrees also equals to square root of 3 over 2.
Good. So that h equals?
H equals to
This times 8.
Square root 3 over 2.
Yes, 8 times square root 3 over 2, which is 4 times square root 3. So knowing this height, we will be able to calculate this equilateral triangle area. What do you do? 1/2 times base, which is?
4.
This base is 8, and this h is this. Okay? Time makes sense? This makes sense? Which is divided by 2 is 4. 4 by 4 is 16. So 16 times square root 3, correct?
Yes.
Okay. You have how many of them? See, if you draw this thing, it's going to be split into how many of equilateral triangle?
6.
6. So total will be this times 6 give you 96 times square root 3. Okay?
Yes.
And you have 2 of them. You have the top and you have the bottom, which are the same. So you double, which is 192 times square root 3. Okay?
Yes.
Makes sense? If we cut this one and we open it, it should be a rectangle. How do we calculate each of the area? This is how much?
That is 72.
72. And you have how many of them? You have 6 of them. Yes? 1, 2, 3, 4, 5, 6. You times by 6. This is called the lateral surface. Look at here. This whole thing is called the lateral surface. This two thing is called the top and the bottom surface. Okay, that's number 2. Now number 3. Number 3 is similar as number 2. I want you guys not using this given one because we learned trigonometry. So we can do this by ourselves. Okay. So let me call next student, Bella. Let's try here. This is a pentagon for the top and also bottom. As a pentagon, we want to figure out the center angle. This is a pentagon shape. How much total is this angle?
I don't know.
This total is 360 degree. Your angle surround one circle is 360 degree. All this is 360, yes? 360, and this 5 are going to be equal. So you do 360 divided by 5. That makes sense?
Okay.
360 divided by 5 is how much? How much? Go.
61.5.
Wait a moment. You learned the number sense with me. You have this foundation. You double. This double is 720 divided by 10. So you can calculate this quickly to be 72, right? Each center angle here is 72 degree. If you draw this thing as an altitude, and that guy split this into 2 equal pieces, 72 divided by 2 become
36.
36. Now go use the trigonometry we learned. Each pentagon side is 13. All the side 13. We want to calculate that. You want to use which trigonometry? Sine, cosine, or tangent? You want to use which one?
Cosine.
You want the cosine. But if you want to use cosine is adjacent over hypotenuse. You don't know this line either. Some people say this is also 13. No, hold on. That's not an equilateral triangle. Nobody say this is equilateral triangle. I didn't say this is 60, 60, 60. So you cannot suppose this equals that. So you don't know this green line yet. You only know this is 13. And you know this is half of 13. So you want to use which one? Tangent. Yes?
Okay.
This is 36. This two angle is called what? If two angle sum is 90 degree, what do you say?
Complementary.
Yes. So this one here is how much degree?
90 minus 36 is
Yes. 54.
54, yeah.
Good. So you will do tangent 54 equals to who?
Is equal to the opposite, so
H over
H over 6.5.
good. So our H equals to 6.5 times tangent 54 degree. So far, so good.
Mhm.
And then you will calculate this area. How do you calculate this triangle area? Your base is
13.
So you do 1/2 times base times its height to get this triangle area, right?
Mm.
Yeah, so each triangle, by the way, the two students, Lydia, everybody is showing their eyes and the face. Lower down your camera. I need to see your whole face all the time, all the students. Thank you. So you have your triangle area equals to 1/2 times 13 times 6.5 times tangent 54 degree. That is your expression for one of the triangle. And you have how many of them?
5 of them.
5 of them. So you will times by 5. And you have the top and you have the bottom, so you times by 2. In that way, you calculate this top and bottom area. And the rectangle part, you cut this, you open it. You have 5 equal rectangles. So you do 13 by 5 times 5. That's called lateral surface. This is called top and bottom surface. Cylinder, hexagon, prism, pentagon prism. All of this not hard at all. Go try number 4. Do your own drawing. I don't want you to just send me a final value of the lateral surface and the total surface. I don't want you to show me the numbers. I want you to show me you draw a pentagon like this. You figure out those center angle. You figure out this angle. You use the definition of tangent to figure out the height. I don't want to use this 8.9. Don't use this. Use the way I show you here. Show me your work of how you calculate this 2 pentagon area. And show me how you calculate the lateral surface area. Show me your work, send your work, send your picture. I called this question as easy level question. After we go through this easy level question, I would like to give you guys some challenge question, okay? Yeah, I upload a new worksheet. If you have printer at home, please download this one, okay? Yeah, I would like to give some advanced level questions so that when you have this training with me in those SAT, PSAT, or ACT, you don't need to worry about this kind of question. I put it in this folder. You can look at it and you can print it out. We'll finish number 4. You can send me your work. Very good, Ryan. That's super nice. Good. Nice, nice. Ryan, your work is so neat. I like it. Just change your pentagon shape a little bit. Use a ruler to draw something more like a real pentagon prism, okay? Yeah. All your calculation is perfect. Who else finished? Bella, yes. Nice. That's right, Bella. That's good. So this is a basic shape. You calculate the cylinder surface area, those pentagon prism or hexagon prism or a triangular. This one here, this is a triangular prism, okay? The top and the bottom are both a triangle, so you can calculate this two triangle easily. And then you can calculate this full rectangle area. I saw the left part, the previous worksheet, I think it's kind of like too easy. I want to go through this one. This is the real high school geometry, AAC level, okay? Yeah. Some students, you take geometry in middle school. Sometimes they don't give the question as hard as the high school. But if you happen to have a teacher who don't really know how to teach geometry, that teacher will just exactly copy down from the high school teacher's quiz or test. So here, please print out this one. If you haven't print out, please print out this one. Or you can load it in your good notes. Okay. Let's talk about this. If you don't have printer and you don't have good notes either, you just do with me. Watch my screen. Okay. And you can do the printing later. This first one, that's a tricky one. Right, let's see here. The plane region is revolved completely about the y-axis. This region is revolved, so you treat this as your center. Everybody see my camera. So basically, you are using something to do the rotation. So, for example, I have this, okay? Yeah. I use this one as a line, and I use this rectangular shape. I want to make this rotate around, okay? Use this shape to rotate around all my arms. That is coming to what? Right, look at this. Run, unmute yourself. See, this guy is revolving around this center line. So the outline here, this one has revolved to come to a circle. Yes?
Yeah.
And the inner one revolve, become a small circle. So this guy has a big circle, and this guy has a small circle. So this gives you a shape of a cylinder. Does this make sense?
Not really.
Everybody, look for something, a small rectangular shape. Go, everybody. You can get a piece of paper, everybody. Or you can use your phone, okay? You can use your phone. And you use one arm. I need to see your hands-on activity in front of the camera. Everyone, okay? Use this arm as this center line, and you are going to rotate your phone, okay? Don't rotate this by itself. Just rotate this around your arm. Everyone, do the same thing. What kind of thing you form? That's a one cylinder inside the other. This one inside is empty, okay? There's nothing here. There's nothing here. And all the other things is formed by that guy rotate 360 degrees around this center. Right, does this make sense now?
So is it 3D?
Yes, of course, we are doing 3D. We are doing 3D geometry, okay? Yeah, our 2D, except circle, we already finished. We will leave the circle after the 3D geometry because the circle is the most difficult part for geometry. So we will leave the circle parts, but every other 2D geometry we already finished. So we are doing this. So the inner one is this small cylinder, and the outer one is that. And this thing, because you are using this to revolve, so this thing here, this is solid, okay? This is solid. Do we still have people say, I cannot understand this? Any people? If you still don't understand this, what you can do? You have Play-Doh at home. You can use your Play-Doh to do this kind of exercises. You see the shape, yeah? You see what I mean? Or you may eat ice cream, yeah? If you have a nice ice cream cake, and then you can use some cup to cut a hole inside. And the rest of them is this geometry. So the big one is a big cylinder. The smaller one inside is a small cylinder. And this two circle is concurrent with this center, okay? This two circle is concurrent with this center. Now, The small one, radius is how much? Right. Who is a small circle radius?
1 unit.
1 unit. What is a big one circle radius?
4 units.
4 units. If I ask you the letter surface, what you do? The letter surface is saying if you want to paint, you paint the surrounding without touching the top and the bottom. So the inside one is this cylinder letter surface. The outside one is the big cylinder letter surface. Does that make sense?
Yeah.
So the smaller one, your radius is 1, so you have 2 pi r times h. 2 pi times 1, which is this guy you cut open as a rectangle. This one you cut it open as a big rectangle. So this big one is 2 pi times 4. Smaller one is 2 pi times 1. So you do this sum and you times by 2, which give you 20 pi. But that's not the end yet. If I ask you the top and the bottom, how do you calculate? What do you think? How do you calculate the top and the bottom? The top one, bottom one is what? It's a big circle who cut the small circle, correct? Yes. It's a ring. You understand? The top and the bottom are both a ring. Use the big triangle, circle area, which is pi r squared. R is 4. R squared is 16.
Okay.
Smaller one, R is 1. R squared is 1. So 16 pi minus 1 pi equals to 15 pi, double 30 pi. The lateral surface is 20 pi. This top and the bottom ring area is 30 pi. So you do this summation, which is 50 pi. Is this too hard?
I just never learned it.
It's okay. I teach you. Now you can understand. Next one. Number 2. Lydia, go ahead, unmute yourself. Lydia, unmute yourself. The total area of a cylinder. We did the cylinder area just now. What is the total area for cylinder for me?
Like
What is the
Surface area
lateral
or the-
surface?
the surface area?
First, what's the lateral surface? First, what's this? Look, what is this area? This is called the lateral surface. What's that?
2 pi r.
By h.
Mhm.
And then you have
2
this
pi r squared.
and that. Yes. Make sense?
Mhm.
Go. The radius you don't know, but they give you the height. Yes?
Mhm.
Go.
40 pi equals 2 pi r times 8 plus 2 pi r squared.
So 2 pi r times 8 plus 2 pi r squared. Very good. You want to solve the r? Both sides has pi. Can you please cancel?
Do I divide by pi?
I will divide by 2 pi for each one. Go.
20 equals to r times 8 plus r squared.
Okay. So that means you have r squared plus 8r minus 20 equals to 0. Then you can do who times who.
10 and 2. Negative.
Yes.
Sorry.
Good.
10 and negative 2.
Good. So your r equals
2.
2. We don't make the radius equals negative. So I only take the positive 2. That's it. Okay. This is typical SAT math question. Okay. This is a very typical SAT math question. You don't feel surprised at all if you see this kind of question. Yeah. Learning today's class, if it can help you improve your SAT math by 20 points, your parents will be really, really happy. Okay. Really, really happy. Number 3. This one is also a little bit tough, but not so that bad. Not so that bad. May, unmute yourself. Let's try here. You want to calculate the letter surface. So letter surface, we treat this guy, that guy, that guy, that guy, that guy, all the way, okay? We treat those things as a letter surface, okay? Go. We can start from this front one, which is who times who?
9 times.
Oh, you want to start from this one? Okay. 9 times 18.
Yeah.
So we put 18 outside because it's all times by 18, you know? So we do 9 plus,
plus
this one here, be careful. They didn't show you this part. This is 9. See here, I need to show you the work. That is 9. So this bottom here will be 9. Yes? This total is 15. So how much is here?
6.
Good. This portion is 6. And then I'm going to draw a line over here. This is also 6, right?
Yeah.
Right. This is total 12. This is 4. This is 4. This is 4. So this is total is 12. So this portion will be 8, correct?
Yeah.
Then use Pythagorean theorem. 6, 8. Here will be how much? 10, right?
9.
3, 4, 5. Double, double, double. Okay? Make sense? So 9 plus 10. Yes?
Yeah.
You don't plus 6. 6 is the inside one. It's not the surface. This is something between. You don't times that. You don't add that one. 9 plus 10. Then you want to plus who?
12.
12. That's this area. Yes?
Yeah.
Okay. Plus 12. And then you want to plus who?
15.
Good. You plus 15. And then you come back, you plus who?
4.
Yes, very good. And then we want to do this really carefully. See here? This become?
19.
This is 19. If we add this, this is how much?
27.
27 plus 4 become?
31.
31. 31 plus 19 become?
50.
50. This become?
900. Wait.
Yes, that's 900. You can do this. You can see I'm going to times 100 and divide by 2 because 100 over 2 is 50. So this is 900. Okay. So that's number 3. Number 4. We are looking for the total area. Richard. Let's do the total area.
Okay.
We already have all the letter surface. We want to get this two portion. Okay.
Okay, so the rectangular prism 8 times 9 times 4. 36 times
Oh,
18.
hold on. So you calculate this part, this become?
That's
Oh, you did
36.
this one. You did this way? You want to do this way?
Yeah.
That's better, right?
Yeah.
15 by 4, yes?
Yeah, 60.
15 by 4 plus, come on, go.
15 plus 4 plus
15 times 4 plus.
15 times 4.
Yeah, 15 times 4 is this. And then 6 by 8
And
by,
then, so
1
that
half
means
times 6 by 8.
24,
Yes.
18.
And then by 2, yes?
Yes.
60 plus 24 times 2. 84 by 2 become?
128.
And then
And
128.
wait, no, 168.
168. And then add. Become?
1,068.
Yes. That's it. Okay? Yeah.
Okay,
How do you feel this kind of question? Tough? Hard?
easy.
Yeah, easy. Not at all. It's not hard at all. Okay? Yeah. I will show you guys some difficult question later. Number 5. This is those words problem. Okay? Let's see here. Emma, you can read the question quickly, please.
Wait, you want me to read out loud?
Yeah.
Or?
Yeah, you just read aloud. You can read quickly. Go.
After installing the right prism in problems 3 and 4 as a cover for outdoor machinery, it was found that the machinery was overheating. In order to correct the problem of overheating, it was determined that a tight-fitting tent-like cover made of reflective material was to be made. This
Hold on. So what did they say? This whole 3 lines is saying you want to have the surface area. Next.
This reflective material comes in sheets that are 4 by 8. The contractor who is to make it doesn't care where or how many seams he makes. If each sheet of reflective material costs $68, how many sheets will he need and how much will the reflective material cost?
So let's see. They want to cover which part? After installing this thing as outdoor machine, that this is overheating. So they want to correct it by doing some material. And the material is using the shape as 4 by 8. Yes? And the dollar amount for each part, for each sheet is 68. So we want to figure out how do we calculate how many pieces we need, right? Yes?
Yes.
Okay. And then we coming up to this. Let's see here. What's going on? Why I do this minus? Why I don't do this? It's kind of weird. It's okay. I'll come back to this question later. Let's see number 6. They want you to find the letter surface and the total surface of a regular hexagon. We did this same question just now, right? Yeah. You can draw this hexagon split into 6 equal letter triangles, and each edge is 10, so you can have the altitude here calculated quickly. Or you can just say this is 10, this is 10, and this is 5. This is 5, this is 10. 5 double is 10. 5 times square root 3 is this height. So you can easily calculate this equilateral triangle area. And you times by 6, which is the top. You double, which is the top and the bottom. And all the letter surface area is the 6th of this rectangle area. Next one. This is the shape of those lunchbox from the Chinese restaurant, right? And you can see this thing. This is a prism. All the previous one, we're dealing with the prism. This one is a pyramid. If you have a top, which is not the same shape as your bottom, but just a point, this is no longer a prism, it's a pyramid. and they give you the slant height. Slant height as 17. The altitude here as 8. If they give you the slant height and the altitude, then you can do the Pythagorean theorem. Okay, that's the reason I ask you guys remember those Pythagorean theorem so that you can do this thing way more faster. So let me call student. Elizabeth, do you remember those Pythagorean theorem numbers? Go ahead. How many do you remember?
I don't really remember that many.
At least you know the easiest one, which is
3, 4, 5.
What else?
17, 23, 24.
Really? Sounds not right. It's 5, 12, 13, correct?
Yeah.
8, go.
I don't know this one.
You need to remember this. This question show you why you need to remember this, okay? If you don't know this, you do 17 square. Some people even don't know 17 square. You do this thing and you minus this by 64. That's too slow. You know this thing, you immediately know that is 15. You see what I mean?
Yeah.
If you have 7, 24, the third number will be?
25.
Thank you. If you have 9, 40, and then
40,
9, 40, and then
41.
41. Yes, makes sense?
Okay.
And then 20, 21, and 29, okay?
Okay.
You need to remember this from now on, okay? I will still call you again. So this is called altitude, and this is called slant height, and this is called half of the set length. If you know this number so well, you can see this is 15. If this is 15, that will be 30. That will be 30, 30, 30. Your total area, you can calculate each triangle. Each triangle area will be 1/2 times 30 times 17 and times 4 and plus this square. Let's do something. I think for geometry, 3D geometry, if you can draw well, you will be able to solve it very well. So go ahead, let's draw this with me together. If you have a good notes, it's going to be very easy for you. If you don't have a good notes, then you better to look for some ruler and something shape you can help you draw those cylinder, okay? The first one we draw is a cylinder. Go ahead, do it. I said many times, in my class, you don't have your hands work on continuously. You cannot learn anything in my class. This is cylinder. And then I'm going to draw a triangular prism. I on purpose draw the line on the back very thin because that is the line which I'm not able to see from the front position. Okay. This is called a triangular prism. And then the rectangle prism, okay? This class we learn about the total surface, lateral surface. Next class we will do the volume. And for the volume, we will see those composite shape. So being able to draw is the basic foundation part. Third one, rectangular prism. Next, a pentagon. Some people say, why you don't draw? You said it's a regular pentagon. Why you don't draw a regular pentagon? It's 3D. When you draw 3D, you cannot draw like the shape you look down, you know? Just like you look at your room, those shape which should be a rectangular, but when you watch in a distance, it is a parallelogram shape. All of you need to show me your work, okay, before you leave today. Next one is a hexagon prism. Who finished this 6 shape already? After you finish this 6 shape, you will do something like this. Yeah, but only if you have this software. After you finish this, you will duplicate this. And then you do that thing. You may feel curious, what are you doing? I'm just lazy. I save my work by keep all the base, and then just quickly get the pyramid.
Can you go to the last shape again, please?
Which one? This shape?
The last shape. Yes, please.
This one. If you are really good at sketching, you shouldn't worry about this thing. But if you're not so good at drawing stuff, I want you guys to draw it, okay? Okay. If you finish, you can send me a work, please. Thank you, Richard. But I wish you could use a ruler. And also for this, Richard, if you draw a 3D, even it is a rectangular pyramid, the bottom one shouldn't looks like a rectangle. You cannot draw the shape like that. No, you should change this to a parallelogram shape. Okay. Yeah, because if you look at the 3D view, it's not going to be the same way as what you see. Very good, Emma. Nice job. You have some drawing foundations, I can tell. Very good, May. Thank you. Other people? Now with a foundation of drawing, let's see here. Number 8. The plane. This time it's not a rectangular plane. It is a triangle, a right triangle. This one is revolved completely about this center line, x equals to 1. So here, rotation is one thing. The center line is another thing. If this guy rotate around this, you will have a hollow center cylinder between. But this one, rather than rotate over the y equals to the y-axis, it rotates about this green line, which is x equals to 1. So this one rotates about x equals 1. What is the shape? If you know this guy rotate about this center line, if you know that formed geometry's name, you can say it. Who knows that name? Yes, very good. Who said that? That's a cone. Yes. Good, Leah. That's right. It's a cone. If it's a cone, how do we calculate the cone's surface area? Did you guys? Okay. Let's do this. Search in your room if you have a big circle so that you can draw a circle on your paper. Everybody go ahead. Search your room if you have a circle in it so you can draw a circle. Good. Yes, Elizabeth, very good. Yes, Lydia. Go on the paper, draw a circle. Everybody, don't get too small. Something like a size of your hand, okay? Draw a circle on your paper. Draw this circle on your paper and get a scissor. Cut that circle. Everybody go ahead. When you finish drawing the circle and cut the beautiful circle, show me your circle in front of the camera. We do some hands-on activity to let you see how you can get the surface area of the cone. Yes, good job, Richard. I want you to use your ruler to cut 2 lines. Okay? Just suppose the circle you have is a big pizza, and you want to cut the pizza into 2 pieces. One piece is big, one piece is small. Cut something like that. And I will be able to let you use this 2 pizza. You cut one piece to be this big, and you cut another piece to be this small. Okay? 2 parts. You use this one to make a ice cream cone. And you use this one to make a Mexican hat. Go. Good, Nina, that's right. Use a small portion, fold the 2 sides, make it to be a cone. Yes, that's right. One small one, you can make this into an ice cream cone. The big one, you can make a hat and put the hat on your head. Go. You might say, teacher, are you teaching the kindergarten? No. When you know this thing, when you do this from your hands-on activity, this memory will be with you forever. I want you to use a one small one. If you have some tapes, please tape it. Use a small portion. Use this small portion to make an ice cream cone by put this lining up with that. And for this big one, lining up so that you can have a hat. Put the hat on your head. Okay, show me a small hat and show me an ice cream cone. Go. And then I will tell you how do you calculate this lateral surface of a cone. In the future, when you learn calculus, especially calculus BC, the very difficult part is those 3D geometry calculation in those calculus BC. In calculus BC, we don't learn this easy level question. We learn way more difficult shape. But everything starts from here. Good. Thank you, Nina. Thank you, Richard. Thank you, Lydia. If you haven't shown the hat on your head, you need to show it. Let me see. Yes, that's right. You got it. Yes, that's right. Yes. Elizabeth, you have to put the two sides together to make it to be a hat. Okay? Not the flat piece on your head. It's a hat. Yes, you got it. And another part is the ice cream cone. Emma, yes. Okay. All right. And then you open it to flat. You open it to flat. Do you agree with me that if you have a cone, if you want to calculate this lateral surface area, actually you are calculating a pizza area. You guys agree now? Yes? Before you do this, you don't believe so. You after you do this, you believe so. Yeah? Now we are going to calculate this pizza area so that we can calculate the cone's lateral surface area. Here, there is a little bit tricky things. Let's see here. This is my notes. Go ahead, draw a circle on your paper. This time you don't need to cut, okay? This is for your notes part. For students have iPad, draw it on your iPad. Draw a beautiful circle. Draw these two radius and shade this with your favorite color. And now we will cut something here. Draw another cone, okay? Draw a small cone. This is the 3D. Draw the altitude here called H. Draw the radius here called R. Draw this L called slant height. So Lydia, this is height H. This is radius R. How much is this slant height?
The root of h squared times r squared
Plus.
plus, yeah.
Yes. Now we want to calculate this cone's lateral surface. So you will cut this open and it becomes to this shape. Yes? Yeah. So anytime you eat the ice cream cone, you cut this, you open, you have this thing exactly. So we will calculate how much is this. Next. Elizabeth, ask you a question. You make this cone out of this. And now you make it open, make it flat, come back to this. How long is this one? This is who?
The slant height.
Yes, smart girl. How long is this?
The circumference.
Which is?
The circle part.
Which is how much?
Oh.
2 pi r. Yes?
Oh, that's what. Okay.
Yeah, that's 2 pi r. Now, you know that is 2 pi r. And you know that is square root of h squared plus r squared. And now we want to calculate that area. Make sense?
Yes.
Look at this. Do you agree with me that this green pizza area over this whole circle area should equals to this green line over this whole circle? This over that should equals to that over the whole circle area. It is proportional. You agree with me?
Yes.
Everybody agree with us? It is proportional. The green area is the guy you are looking for called lateral surface. And the pi times this radius is that. So the circle area will be pi times that guy square, which is this, correct? Yes.
Yes.
Pi times that guy squared, which is this, should be proportional to this portion is 2 pi r, and the whole circle circumference is 2 pi times that. Okay?
Yes.
This looks complicated, but not so bad. Go ahead. Try to write down this by yourself. I already explained all the steps. We are looking for this. This thing, we can know pi times this guy squared. This guy is 2 pi r. This guy is 2 pi times that. And then you put this to this side, solve this green area. Go. If you're finished, you can show me a sum up, and I can call you to go through the next step. We'll finish the area calculation. This kind of cone lateral surface area is really, really important. That's the calculus BC, most difficult part, 3D geometry, those polar system area calculations, basic starting point, okay? If you want to apply for those top 30 universities, you have to finish those AP calculus in high school and have very good grade. And this is also helping for your SAT. So you have this. Oh, I have a student finished. That's good, Elizabeth. Times this part. Times this part to this side. One more step, okay? Times this for both sides. So this thing canceled. You do one more step. You will be able to calculate who is the lateral surface area. See what you get? You have this over that equals this. The 2 pi canceled. And lateral surface will be this whole thing put on the right. Put this whole thing on the right times r over this. So that guy divided by that guy is this guy. I know this looks like a dangerous, overwhelming, but actually no. This two thing can be easily be canceled. So this is the lateral surface area. The lateral surface area is called pi times r times L. If you remember this way is too much for you, just remember pi times this base circle radius times the slant height. That's it. That's how you calculate the lateral surface. Okay? If I don't show you the steps of having this formula, just force you to remember, you will forget this thing very easily. Okay? Now, for your two small head, the thing here, go write down pi times r times L equals to lateral surface. On your small paper, don't lose it. Write down lateral surface equals to pi times r times L. Okay? Pi times r times L. So come to here. This one revolve. That line is a cone. And that cone's lateral surface is pi times r times L. That's the reason I need you guys to remember this. Because if you know this number, you say, oh, 5, 12, 13. Ah, easy. So 13 is the L. 5 is the radius. So you have the 5 times 13. That's the lateral surface. That's the lateral surface, okay? Yeah. If you want to make your own ice cream cone, you have to calculate the material you need to use, you know? The total surface, you plus the pi r squared. That's it for number 8. Number 10. Look at this. If you can draw it, you can solve it. Go ahead, solve this number 10. Draw this one first. The base is a rectangular base. That's a rectangular base. This base is who? It's 80 by 28. This rectangular base is 80 times 28. And then you can draw the slant height. One slant height on the right, one slant height on the front, at the front. They said lateral edges. You might feel curious, what is this? Lateral edges is this 4 guys. 1, 2, 3, 4. That's the lateral edges. That lateral edges are congruent and has a length of 50 inches. And they ask you the lateral surface area. Oh, this is not a cone, so we don't use the same formula. We want to calculate the slant height. Let's see how do we calculate slant height. Bella. See, this is 80. This is 80. And this is 28. If this is 80, then half of it will be 40, right?
Yeah.
This is 40. The slant height and this 40 and this edges, this is what kind of triangle?
A right triangle.
Right triangle. So you can do the Pythagorean theorem, right?
Yeah.
So you do 50 squared equals to that guy squared plus 40 squared. Make sense?
Mhm.
We know the Pythagorean theorem numbers. 50, 40, you think this will be how long?
30?
Yes, very good. 3, 4, 5. 50, 40, 30. That's right. Very good. That's the reason I ask you guys remember those things. Make sense? Now check here. Go, Bella. This is 50. This is 28. So half of it will be 14. This is 50. This is 14. So we want to calculate that lines, which is H1. Okay? So 14 square plus h1 square equals 50 square. Make sense?
Hmm.
And then we have to, this one, we don't have, we can do also a tricky thing here. Look, 14, 50. Remember we have this thing, yes?
Mhm.
25 double is 50. 7 double is 14. That's why 24 double should be 48. Make sense?
Oh, yeah.
So that is 48. And that is 30. Okay? If you don't know those numbers, then you have to deal with this kind of thing. But if you still strong in the number sense, then it is still not bad. But if you don't know those number sense at all, you will feel like, oh, how do I solve this one? Which guy square is 2204? You don't know. Okay? So you have this thing quickly. By making each guy double, you figure that's to be 48. And that's 30. And then what's your next step? How do you calculate that triangle area?
You do
One
80.
half.
Yeah, 1/2 of 80 times 30.
Yes, plus.
Plus 1/2 of 28 times 48.
Yes. And you have two pairs, so you times by 2, right?
Yeah.
Okay, that's it. Make sense now?
Mhm.
That is number 10, okay? That is number 10. Number 11. Go ahead, draw a cone and draw a cylinder. Draw these two side by side. We just learned the letter surface. So the letter surface is IRL for the cone. So the cylinder is 2 pi RL. But they said has congruent base, which is 7, radius 7. So this is 7, and this R is also 7. And both height of 24. So this is 24. This height is 24. You have the formula. You should be able to calculate all those letter surface area. Go ahead. Calculate the, write down, calculate the letter surface area, calculate the base area, and then do that total surface area, and then do the minus. Who finished? Why this question takes so long?
I sent you my answer.
Oh, okay. Oh, yes, I got it. So you got the difference? This is 175 pi. And then you can do that thing. This is 48 times 7. Okay. So this is 98 pi plus 336 pi. And you do their difference. So you do 336 minus 175, which is 161. And then plus 49, which is 210 pi. Richard, why are we different?
I think I just got the what was it called? The lateral area of the cone.
Yeah, but they ask
Yeah.
you the total surface. But even that, you use 80 plus 49, still not the same answer. Yeah, Richard, mute yourself, please. Or you plug in the pi. When you plug in the pi. Leah, your final answer is 7785. You plug in the pi, right? Why we are also different. Lydia, you see where you did wrong? No, Lydia, it's not 188, it's 168. 7 times 24 is 168. That's where your mistake come from. Okay. You know, when I was in middle school, I was also, when I do question, I know all the math question very well, but I always have all kinds of careless mistake. So you have to really be careful. Those questions, if you don't know how to do it, you don't get the points, don't feel so bad. If you know how to do it, but you get it wrong, you feel really sad. Number 14 is this kind of a composite shape. What they have a cylinder, and on top of the cylinder is a cone. And they ask you the surface area of this composite figure. So you should keep in mind, you don't calculate this circle 2 times because the guy here is not on the surface. This is glued between them. So the lateral surface of this shape is just this cone lateral surface plus this cylinder lateral surface plus a circle area. That's it. Okay. That is what number 14 is. Okay. Make sense? Go ahead, everybody. Do number 14 also. Do this guy pi RL. Do this guy 2 pi RH. This bottom is pi R squared. You can leave the pi so that you don't need to calculate those big decimal numbers. Who finished? It shouldn't take so long. Yeah. Yes, good job, Lydia. You got it. Thank you. Who else finished? Practice make it perfect. Just do as hard as you can so that you can get those questions easily, quickly solved. Okay. Next week, we will talk about the 3D geometry volume calculation. Okay. Yeah. So for example, the shape we see here today, for the first one, when we want to calculate that shape volume, you want to use a big cylinder area minus the small inside cylinder area, because this small one is an empty one. You have a solid stuff between these two cylinders. Okay? Yeah, that's for today's class. I will post my notes also in the Google Drive. Make sure use my notes to help you finish every question. That's for today's class. Thank you, everyone. See you next week.
Thank you. Bye-bye.
Thank you. Bye.